Good morning. It's a little late, but as promised, here's the video for AA1-6, transforming parent graphs. So I'm going to start with those, reviewing what 6 parent graphs you are responsible for. The parabola, that's y equals x squared. The cubic, y equals x to the third. Cube root, y equals the cube root of x. Square root, y equals the square root of x. Hyperbola, or rational, which is y equals 1 over x, and the absolute value, which is y equals the absolute value of x. So if we start with the absolute value graph, off to the side here, what I'm going to do is graph what would be the origin. I'm just going to put a little x to represent that origin. And when you graph your parent graph of absolute value, you start with 0, 0. That's always your locator point with your parent graph. You go out 1 and up 1 in both directions. The reason that works is absolute value is the distance from 0. So if I have the absolute value of 5 or I have the absolute value of -5, either way, my y value is going to be 5. And that came off just a little bit. So there's my parent graph. And then when I look at my transformation, this tells me I have, remember the parent graph, or sorry, the graphing form or the general equation is y equals the absolute value of x minus h plus k. In this particular case, the hk is 3, 4. So that means that I'm going to move my graph right 3 and up 4, and there's my new graph. And that's that for that particular transformation. Next step, I have the cubic. So again, over off to the side, I'm going to draw my little origin there, and my locator point, which is at 0, 0. With the cubic, I go out 1 and up 1, and back 1 and down 1. And then from there, I go out 1 and up 7. So I'm up to there. And that is, whoops. And that is simply because if I have 2 cubed, so 2 times 2 times 2, that's going to give me positive 8, and if I have negative 2 cubed, that's going to give me negative 8. So that's my parent graph. I'm going to come over and put that on my grid here. So keep in mind the points that I'm showing you down here, that 1, 2, 3, 4, 5, those are the important points that I want you to graph. Now, my x minus 4, it's cubed, minus 2, means that I'm going to take that graph and I'm going to move it right, I'm going to move it right 4, and move it down 2. Next up, I have a 2 out in front. Whoops, wrong one. I have a 2 out here for my a value, which I haven't done before. This is my parabola, which normally, if this is my origin, I would go out 1 and up 1 and out 1 and up 3, and that would be my pattern. But because of this 2 out front, I'm going to undo those 2. I'm going to go out 1 and up 2 in both directions, and then I'm going to go out 1 and up 6, because that growth pattern gets multiplied by 2 every single time. So then I take that and I put it at my origin. So that's my parent graph that's been multiplied by 2. And now I'm going to move it according to HK. So if you deal with the stretch factor first, then you can just move the locator point. So I'm going to take the locator point and go down, or left 3. That's that plus 3, remember, if this is x plus 3, that's really x minus a negative 3. So my locator point is negative 3 and then negative 1. So remember, h is the opposite direction of what you would expect, left or right. K is exactly the direction you would expect. So my absolute value, sorry, not absolute value, my rational equation, my parent graph, I'm putting a dashed line at my y-axis and at my x-axis. Because the locator point for a hyperbola is actually the point where my two asymptotes meet, and I'll talk in a moment about why there's an asymptote there. So if I'm graphing this, remember it's just 1 over x. So if I have 1 over 1, my y value is 1. If I have 1 over 2, my y value is 1/2. If I have 1 over 3, it's 1/3. It's just going to keep getting closer and closer and closer to that x-axis, but it's never going to touch it. In the same way, on the other side, if I have negative 1, it's negative 1. Negative 2 is negative 1/2. Negative 3 is negative 1/3, so on and so forth. And I'm just going to keep getting closer. Now, I have an asymptote where x equals 0 right here because I can't put in 0 for x, because I can't divide by 0. But if I put in 1/2, then I get 2. If I put in 1/3, I get 3. 1/4, I get 4, and so on and so forth. If I put in 1/100th, I'm going to get 100. So this gets, just like on the other direction, closer and closer and closer and closer to the y-axis. So this forms my hyperbola. Now, the important parts to draw in a hyperbola are the asymptotes. That's the first thing you should draw, and that is my expectation when you graph this, that you draw those asymptotes in dashed lines. Feel free to use a different color. That makes it a little easier. And then the 2 points that I want to see are these 2 points right here and here, in case you didn't notice me draw those in, right there and right there. So I'm going to take my parent graph, which lives right there. My HK, x plus 3 means my H value is negative 3, and then my K value minus 5, sorry, got distracted by something on my screen, means that it moves down 5. So now that's my new hyperbola, also called rational. All right, square root graph. Starting again at 0, 0, and I'm not even going to mess with my grid. If I put in square root of 1, I'm going to get 1. I'm not going to use 2 or 3 because those don't have perfect square roots, so I'm going to go square root of 4 equals 2, and then square root of 9 equals 3. So that is my square root graph. And we talked about it in class. You could make the argument for a lower half of that that would continue to go down here as well to make it a sideways parabola, but then it wouldn't be a function. So we're going to stick with the top part. So that's my parent graph right there. I'm going to move it 5 to the left because of the plus 5, and then down 2 because of that minus 2. And that's my new graph. And lastly, I have the cube root, which I am going to draw in just a small grid here. Cube root is what times itself gives you that number. Of course, 0 times 0 times 0 gives me 0, so the cube root of 0 is 0. Cube root of 1 is 1. Cube root of negative 1 is negative 1. The next thing that's going to have a perfect cube root is negative 8 and positive 8, because 2 times 2 times 2 is 8. And negative 2 times negative 2 times negative 2 is negative 8. So I'm going to go out to positive 8, 2, and negative 8, 2, negative 8, negative 2, I should say. And then I'm going to draw my graph. And then I'm going to place it where it belongs over here. And then I'm going to move it according to my HK. So right 2, opposite direction of what we would expect, down 5. All right, and that is your transformations for your basic HK transformations. Pardon me. Transformations of A are going to vary a little bit from graph to graph, so that's an extra practice thing that you should do for yourself and make sure that you check your answers and see how you do with it. For your next class, next test, we're going to have the second opportunity on the step and piecewise functions. You can use a half page of notes for that and no calculator. The parent graphs, you need to do 3 of 6 of those for proficient and 5 of 6 for highly proficient. No notes, no calculator on that. And then transforming the parent graphs, what we were just working on, you need to be able to do 2 changes for proficiency level and up to 4 changes, so a negative A and then a different value for A for highly proficient. That you can use your parent graph toolkit on, but no calculator. All right, and that's it. Hope you guys have a lovely day.